I came across this problem posted on Wyzant well over a year ago, but I thought we'd take a look at it. So we've got triangle ABC where side AB is 10, side AC is 9, and the angle between them has a cosine of 3/8, which means that angle is about 68 degrees. And we're told that the area of triangle APQ is half the area of triangle ABC, and where P and Q lie on AB and AC respectively. And we're supposed to find the minimum distance between P and Q. So this shows the area of triangle ABC is 41.7. This is the target area for APQ, half of that. And if we set up P correctly, it will be half of that area. We'll see that on the next page. But for this setting of P, which is 5, which is the minimum value for P, by the way, the distance from P to Q is 8.5. If I go to board 2 and change P to 6.53, Q moves over here to the left. The distance between P and Q is about 7.5. But the area is still what is required. One more example, if I move P all the way up to point B, P is 10, the distance from P to Q is 9, even though we're still, APQ is half the area of the big triangle. Okay, so how do we find P and Q? Well, so if we let little p be the distance from A to point P, then the coordinates of point P are P cosine of whatever this angle is, comma P sine of that angle. And, we're going to figure out how to find the coordinates of point Q along this line right here. AB is 9, AB is 10, AC is 9. The area of triangle APQ is half the area of triangle ABC. The area of triangle APQ is 1/2 the length of the two sides that include angle A, P times Q, times the sine of the included angle. And we want that to equal half of the area of the big triangle, which will be half of 10 times 9 times the sine of the included angle. Well, conveniently, the 1/2s cancel out, the sine of A's cancel out. Half of 90 is 45, so Q has to be 45 divided by whatever P is. That has to be Q. And by the way, we'll make this observation here. Q has to be between 0 and 9, including the 9. So if I replace Q with 45 over P and solve the inequality for P, I get P has to be greater than or equal to 5. If P is less than 5, Q moves outside the triangle. Okay, so now that we've got formulas for the coordinates of P and Q, we can come up with a formula for the distance from P to Q. So it'll be the square root of the change in x squared plus the change in y squared. That's what this is right here. And if I square this binomial, which I've done here, and notice that these two terms both contain P squared, I can kind of picture writing those next to each other, factor out of P squared, and I've got cosine squared A plus sine squared A, which is just 1. So I can replace those two terms with just this P squared. Plus 45 squared, P to the minus 2, minus 90 cosine of A. There's a formula for the distance from P to Q based on the distance, this little p right here. Okay, and if I want to find out what value of P generates a minimum value, this topic was listed under geometry, but it turns out if we take the derivative, set it equal to 0, we'll get a critical number, which turns out to generate a minimum distance, which we could prove by the second derivative test. But the derivative is 1/2 times this expression under the radical to the minus 1/2 times the derivative of the inside. And that's what we want to focus on. The derivative of p squared is 2p. The derivative of 45 squared p to the minus 2 is minus 2 times 45 squared. Reduce the exponent by 1. That becomes p to the third in the denominator. And this is a constant. Minus 90 times the cosine of a we're given is 3/8. So that's just 0. And so we've got, if I want to solve this equation right here for p, I could picture setting it equal to 0, multiplying both terms or every term by p cubed. Solve for p to the fourth, I get 45 squared. The fourth root of 45 squared is the same as the square root of 45, which is 3 radical 5. So when p is 3 radical 5, the distance from p to q will be a minimum. Again, you could find the second derivative to prove that that's a minimum. And so if you want to find the distance from p to q, you plug 3 radical 5 into this expression right here. I'll show you the simplification leads to this right here. There finally is the minimum distance from p to q, 7.5. There you go. Hope that helped. Well, probably nobody's going to look at it, but just in case you do, if you have any questions, post a comment.